Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 13th, 2025, just yesterday. The striking result is that reinforcement learning after next token prediction rapidly amplifies long, high-reward chains of thought, pushing models to generate longer reasoning and achieve strong generalization, with a clear tipping point. Greedy decoding fails when long demonstrations are below about 1/3, and reinforcement learning then drives lengths upward. The paper is titled, How Reinforcement Learning After Next Token Prediction Facilitates Learning, and the implications for model training are quite significant. Beyond theory, the study shows these dynamics on parity, multiplication, and math benchmarks using STAR, Reinforce, and GRPO, explaining why post-training works so well. Alright, that overview set the stakes. Figure 1 shows the setup on the left, where data mix short answers with long chain of thought traces. Then next, token prediction learns a length-calibrated model, and reinforcement learning applies a guess and check loop that up-weights high-reward long generations. On the right, the accuracy curves plateau near 50% during pre-training, then rise sharply once reinforcement learning begins. The lower plot tracks median response length, which increases during reinforcement learning as longer chains become preferable. So the previous figure laid out the setup and overall effect. Figure 2 presents pre-training on parity with 3 panels that track accuracy and response length. The left panel shows accuracy staying near 50% when long chains are rare, but climbing to about 100% when long traces are plentiful. The center panel reports the probability of producing maximum length responses, which mirrors the mixture weight and only rises under greedy decoding when long traces dominate. The right panel highlights a sharp threshold near 1/3, where final accuracy jumps from chance to perfect. So that threshold was stark. Figure 3 shows post-training kicking in across methods and temperatures, where greedy accuracy rises from chance to about 100% within only a few iterations. The left panels compare algorithms and reveal consistently fast gains, while high temperature weakens STAR with end-to-end reward. The right panels display length heat maps that shift from short to maximum length, which signals longer reasoning becoming preferred as rewards upweight successful long chains. So, while Figure 3 showed rapid gains after post-training, Figure 5 compares 2 domains and makes the effect concrete. The left panels track 5x5 multiplication with GPT-2, where the red pre-training curve stays flat, near 0 accuracy and short length, while the blue GRPO curves jump to about 100% and long answers soon after checkpoints. The right panels report GSM 8K with Llama 3.2, where stars mark weak supervised checkpoints and colored GRPO runs steadily raise accuracy and response length toward the full chain baseline. Well, the previous figure contrasted domains. Figure 13 quantifies the sample complexity gap. The plot shows the gap in sequences on a logarithmic y-axis, rising sharply as input dimension increases from 6 to 12, which means pre-training alone needs orders of magnitude more data. By dimension 12, the gap reaches tens of millions of sequences. Error bars indicate variability across 3 seeds, yet the upward trend remains clear. Alright, 2 takeaways stand out. Reinforcement learning after next token prediction, upweights rare, high reward long chains, which pushes models to lengthen their reasoning and quickly reach near perfect accuracy, and the sample efficiency gap is huge, so post-training can replace vast pre-training data. The broader implication is clear. Design rewards and datasets that reliably surface long, correct chains. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.